Welcome to another exercise for the workbook Statistics. This time we're going to talk about confidence intervals for the variance. So our task here, the hourly wages for the employees of a local meat processing plant are distributed as follows. And we get this data set, and our question, calculate the uncorrected variance, or task rather, calculate the uncorrected variance, and determine, based on the data set and the results from part A, a 95% confidence interval for the theoretical variance. So this variance we calculated in part A is just an estimate, and we want to know in which interval with a 95% confidence the real variance will lie. So let's start with part A. First we're going to need the mean. So what we're going to do is simply add up all the observations, the first part, dividing them by the number of observations. Here we had 10 observations, adding all the 10 up, dividing by 10 gives us 12 as an average. This average or mean we can use to calculate the uncorrected sample variance, which simply is squaring all values and adding them up. Again, dividing by 10. So it's the average of the squared values. To make this a bit shorter, I summarize some of them. So here I see I have 4 times the 11. So just go 4 times 11 squared. I have 2 times 12. So I go 2 times 12 squared. Adding all of this up, dividing by 10. And then I subtract 12 squared. The 12 is actually the mean from the part before. This gives me my uncorrected sample variance, in this case of 2.6. So at this point I already finished part A, and I have the most important part I need for my part B, for the confidence interval, which is the estimated variance. That's the 2.6. Because I need this as an input for part B. If I want to have a confidence interval, I'm going to use this formula. This formula where I have on the one hand this estimated variance, that's what I just did here, n, the number of observations, which here is 10, and I need this or these two chi-squared statistics. So at this point I need 10 minus 1, 1 minus alpha half, alpha being the margin of error. So here I'm going to work with a 95% confidence interval, meaning the margin of error is 5%. So I'm going to work with 1 minus 0.5 times 5%. So I'm getting here 0.975. And here I'm working with 1/2 times 5%, so I'm getting 0.025. I'm going to look up those two values in my table, leading to, first off, a value of 19.023, and second, a value of 2.7004. Up here, we always have 9 times 2.6, the 9 being 10 minus 1, the 2.6 being the sample variance. Well, then I just have to add this into add this in a calculator, giving me final result for the confidence interval of 1.2301 and 8.6654. Meaning, while this is a good estimate for the variance, I know with a certainty of 95% that the true variance will be somewhere in this interval. And that's actually pretty wide. Why is this so wide? Well, because we only have 10 observations. And that's actually, it would be much smaller if we have much more observations. So at this point, we do not really know so well how much fluctuations we have in this data set. But well, that's it. And well, this also concludes this exercise. So I hope you enjoyed it. I say goodbye and see you next time.